Most teams bolt a separate vector database next to Postgres. You probably don't need to. Azure HorizonDB does vector, keyword, and retrieval inside the database. This is for engineers building search or retrieval augmented generation. The unlock is DiskANN filtering. It keeps high recall over millions of vectors in one query. I'll show why HNSW quietly loses recall 2 scenes from now. We covered 3 things: vectors in SQL, DiskANN filtering, and hybrid retrieval. One of them fixes a bug you didn't know you had. Start with PageVector. The extension is literally named vector. You add an embedding column typed as vector with your model's dimensions. Then you query nearest neighbors with distance operators. L2 distance uses the arrows operator. Cosine distance uses the equals arrows operator. Inner product uses the hash arrow operator. Embeddings sit right next to your relational rows. No sync job, no second system to reconcile. Here's the column definition and a filtered nearest neighbor query. Here's the gotcha I promised. Real queries filter by tenant, category, or date, plus similarity. IVFFlat and HNSW run the approximate search first. They filter afterward. So a selective where clause throws away most candidates. You asked for 10 results and the graph only found 3 matches. Recall quietly collapses and your top results silently go missing. The more selective the filter, the worse it gets. This is where a naive Postgres vector setup betrays you in production. DiskANN advanced filtering fixes it. It pushes your predicates into the graph walk. The traversal keeps going until it fills your limit with rows that pass the filter. One pass, one SQL query, high recall over millions of vectors. No overfetch hacks, no shrinking your result set. HNSW post filters and recall drops. DiskANN filters in graph and recall holds. That single pass predicate pushdown is the real reason to run retrieval here. It's the difference between correct results and quietly wrong ones. Vectors alone miss exact terms like product codes and names. So run hybrid search. Combine vector similarity with full text BM25 ranking from PG_text search. Then merge both result lists with Reciprocal Rank Fusion, RRF. Semantic meaning meets keyword precision in one ranking. RRF just blends the ranks, so no fragile score normalization. This is my recommended default for most production search. Pure vector search is rarely enough on its own. Keyword recall catches what embeddings drift past. Now build retrieval augmented generation on the same rows. The Azure_A extension generates embeddings in database with create_embeddings. No round trip to an external pipeline to embed text. Wire it into Azure AI Foundry tools for your agents. Retrieval grounds answers on your own transactional data. One store means transactional consistency and no external sync to drift. Your embeddings and your source rows commit together. That's the operational payoff of keeping retrieval inside the database. A few honest caveats. HorizonDB is preview, so behavior and limits will change. Check the current Azure docs before you commit an architecture. Build your DiskANN index and tune it for your recall target. Rule of thumb: measure recall against a labeled set, not vibes. And a single database is simpler to operate, but it shares one resource budget. Heavy retrieval load competes with your transactional queries. Watch that trade-off as your vector count grows. Recap: store embeddings next to relational data with PageVector. DiskANN advanced filtering keeps recall high under selective filters. HNSW and IVFFlat post filter, so they don't. Add BM25 and RF for hybrid search as your default. Embed and ground in database with the A_I extension. One store, transactional consistency, no separate vector database to sync. Try the DiskANN filtered query on your own workload and measure recall. If this helped, do me a favor, hit the like button, subscribe, and tap the bell so you don't miss the next one. See you in the next video.